for inviting me to give this talk. The theme of the Science Congress is Science and Technology for National Development. He mentioned about the Pokhran test. I've always said national development and national security are two sides of the same coin. The greatest advantage of recognized strength is that you don't have to use it. And the greatest disadvantage of perceived weakness is your enemy may get adventurous. So we must be strong, militarily strong, so that we don't have to use our strength. And we can concentrate on development initiative, because development without security is vulnerable. The topic of this thing, as I will develop, is, we want to be economically developed and scientifically advanced, and we have got to do a lot of things which I have shown there. Excellent research and innovation ecosystem. We should excel in basic research, we should excel in applied research, in technology development, R&D led innovation, all this backed by high quality manufacturing skills. But today, we must also go for international partnerships. India of today is not the India of 10 years and 20 years back. And what I'm going to show, maybe it is there in one of the latest slides. Today's India wants international partnership on an equal partner basis. We don't want doles from other countries. And this Science Congress has been very well organized. I must compliment Dr. Narayan Rao and his colleagues for the organization of this Congress. You have an opportunity to meet leading scientists, including scientists from abroad. You had a wonderful lecture just now on the strangeness of the quantum. Quantum physics started as basic research, the wave-particle duality, mass, E is equal to mc squared and all that. But towards the end of the talk, he was talking about quantum technologies, quantum communication, quantum computing, quantum cryptology. So these are things which are beginning to emerge. And I do hope, particularly the young people, will talk to the distinguished scientists here, both from India and abroad, so that partnerships can be developed. Now, there was a talk by the president of the AAAS, which was published in the Science in November 2013, and he used the word appropriability conundrum. Appropriability. This appropriability is a very unusual term, not in the sense of appropriate technology and all that. Appropriate is you have something, I take it away from you, I appropriate it. So his feeling is that you can do excellent basic research, but the person who will get the benefit from the knowledge generated by your basic research is the person who is equipped to do the follow-up applied research, technology development, and then followed up by manufacturing. And the concern of Mr. William Press was that the fruits of basic research being done in the United States may be taken away by other countries, Japan and Europe and all that, and how should they strengthen themselves internally so that the results of basic research done in their country can benefit the United States itself. Of course, we have to paraphrase this in the Indian context, because as India is growing, of course we must do basic research. You can build a technology superstructure, but the foundation for that comes from basic research. Even basic research for which there are no obvious applications. Gravitational, Prime Minister talked about gravitational waves. Gravitational waves, and we are going to get the third leg arm. It's as basic as you can get, basic research over there, or talk you heard from Professor Kajita about neutrino oscillations. I'll mention briefly about looking for the Higgs boson. But these are all things for which, as a civilized country, as a part of the civilized world, we should be able to ask and answer questions about the ultimate structure of matter, or the origin of the universe, and of course so many other problems. The trend is very clear. The mobility of scientists, particularly physicists, is increasing very large. People are moving around now. People are not stationary in one place. And according to the NSF, they had done some statistics a few years back. Almost 1/4 of research articles in 2010 featured authors from more than one country. 25%. 20 years back it was 10%. I'm sure it is rising. More and more international collaborations, international partnerships. You do jointly, you take up projects, and then of course you publish the results of that. Now, of course, India in the last couple of decades, has been going in for big international cooperation in mega science projects, in mega technology projects. One of them is the Large Hadron Collider. Large Hadron Collider is run by the Center for European Nuclear Research. India is an associate member, as the United States, Japan, China, and all that. And they were looking for the Higgs boson. This was the only missing particle in the standard model in particle physics. And because they expected the weight under the standard model for this to 130, 150 times the mass of the proton, they had to raise the energy of the colliding particles to several tera electron volts. And you know, as many of you know, this is a tunnel, 26 kilometers in circumference. These protons are moving around in opposing orbits. Once in a while they come together. Once in a while. The bending of the protons is done by dipole magnets, but the corrector magnets, which focus the beams, all those were supplied by India. Sextupole magnets, octupole magnets, decapole magnets, 1,800 of them. In fact, this was an agreement I signed when I was Chairman Atomic Energy Commission. And what we found was $40 million is at European cost. High precision engineering can be done in India at half the cost. We actually spent only $20 million. Half of the $40 million, a little more than that. And half of the $40 million was our contribution to the LSC. The remaining half is an India fund which supports our scientists from atomic energy and universities when they go and do the work. They go and do the work over there. The detector which found the first signatures of the Higgs boson, the CMS detector, the Tata Institute of Fundamental Research and the group with them was responsible for building this detector. And yes, and the live data from these detectors comes to the Tata Institute. Similarly, Alice detector to the Calcutta group. Live comes because of the National Knowledge Network. The European Union grid is connected to the high-speed optical fiber network, which is the NK, and I'll show a slide for that in a little while. So we are now connected, and so India has not only helped in building the machine, and if you go around the ring, you will find all that when it comes here, and also some other equipment, you will say India there. We are also participating in the ITER because fusion is a long-term possibility for generating energy, and there is one big project, International Thermonuclear Experimental Reactor. See, many of these projects are so expensive and so difficult from a scientific and technological point of view that international collaboration has become more or less inevitable. So there is one such project in Cadarache, France, in which all countries, India is also a member, and India is going to contribute equipment for that, like this, being made by the Institute of Plasma Research. This huge cryostat, which will house entire tokamak, is being built by Indian companies under the supervision of, because whatever contribution we make is in kind, it's not a cash contribution to the machine. We have always been proud of our space program, particularly this robust polar satellite launch vehicle, PSLV. It has had 32 successful launches, including Chandrayaan and the Mangalyaan, Mars orbiter and all that. And not only do they do this for our own use, communication, water resource mapping, looking at places which are under distress, but they have also launched 75 satellites from 20 countries, and for which of course we charge them. And their system Gagan, which has got 7 satellites, just like GPS it will provide over this part of the world, was the last of the 7 satellites was on April 28, and the Prime Minister said, "You are welcome. This constellation to be used by the other SAARC countries." ISRO has been using the French launch vehicles for its geostationary satellites, but now it has its own GSLV capabilities. Now, the Ministry of Earth Sciences, we had a tsunami some years back over the south coast of India. When you have an underwater earthquake beyond a certain magnitude, 7 and more, it can create a tsunami. And then they started building this Indian Tsunami Early Warning Center, and it is now not only it's working extremely well, it detects all these earthquakes occurring on the ocean floor, but UNESCO a few years back designated the Indian Tsunami Early Warning Center as a service provider for all countries on the Indian Ocean Rim. This is an example of an international partnership. India is today willing, big facilities that it builds, make it available to other countries. This I got it from Dr. Rajivan, who is Secretary, Ministry of Earth Sciences. We have our own synchrotron radiation sources. Indus 2, there are two rings there, Indus 1 and Indus 2. Indus 2 is the high energy ring, 2.5 GeV, can give you hard X-rays. Beam lines are there on the dipole magnets, and now they have put insertion devices, wigglers and undulators, and this is working extremely well. Of course, we are also thinking in principle of building the next generation synchrotron radiation source, but better sources which are built later can be accessed by us through various programs of the Department of Science and Technology, a Department of Biotechnology. I have given the list over there. You can use it in a project mode, the Advanced Photon Source in Argonne National Lab. You can build and own the beamline instrument. My colleague in Bach, Milan, has built this beamline in Milan Sanyal in this photon factory in Sukuba. Or you can build it in the superconducting. You see, you have a dipole magnet beamline, you can have a superconducting Wiggler beamline, higher magnetic field, so harder spectrum, critical wavelength, it goes down. Electra in Trieste. India is also willing to buy beam time, 25% or whatever of the B14 beamline at ESRF, which is a macromolecular crystallography beamline. It's made available to Indian scientists. We own it. So we decide how we will use it. This is by the Department of Biotechnology. And of course, the new Petra 3 at Hamburg. In fact, we have paid for building and maintaining one beamline. So DST and DBT also make arrangements for accessing international facilities. We have research reactors in Trombay. Dhruva is the most powerful one so far. But there is another kind of neutron source one can build, which comes not from fission, but from spallation. If you have a high energy beam, GeV kind of proton beam hits a high Z target, neutrons kind of boil off from that. Those are called spallation neutrons. You can surround it by a thermalizing system, and then it becomes a very powerful neutron source. It's called a pulse neutron source. The biggest challenge is to build the high current proton accelerator. And on that part of it, we have collaboration with the Fermilab in Chicago. And of course, the RF cavities, what we do here is also useful for them. And these two solenoid magnets made by RRCAT, designed and tested by Bach, have been supplied to Fermilab and installed in their proton injector. This is the trend now. When you build big facilities, everybody, whether it's from India or people, because Indian capabilities are also now at a very high level, and you young guys who are sitting behind, by the time you begin to grow up, you will be contributing more and more to such international facilities. Mentioned about gravitational wave, this was the spectacular or the sensational news which Einstein had predicted 100 years back. US has got two detectors, one in somewhere near Hanford, one in Louisiana state. They found the first signature of the gravitational waves. What the signature of the gravitational waves will be was done by Rajiv Dhurandhar of IUCAA. Some of the work had been done by Vishweshwara from Raman Research Institute. Indians had contributed to some of the early predictions of these gravitational waves. And now, you see what happens if you have only two detectors, you can only see somewhere on this horizon. There is a source of gravitational waves. If you want to triangulate and focus it, you need the third arm. And this third arm of the LIGO detector, LIGO's expansion I have given there, Laser Interferometric Gravitational Waves Observatory, which are absolutely small displacements it can look at. And it has been approved in principle by the Indian government, and now it will be built in India. Nuclear power is one area where there is need for increasing collaboration. This Director General of IAEA already has said India is the forefront of technological development in the nuclear sector, not least in the area of fast reactors and related fuel cycles. You know, you can have the open fuel nuclear fuel cycle, throw away the spent fuel as waste. But on the other hand, the sensible thing to do is to take out the plutonium from that and put it back into new kinds of reactors. The kind of fast reactor we are building in Kalpakkam, prototype fast breeder, 500 megawatt electrical. We have got more than 25 years experience in handling a test reactor. And he was referring to our Indian 3-stage program, because we know that nuclear is a mitigating technology in the context of the climate change threat. But if you want it to be a sustainable mitigation technology, you have to close the nuclear fuel cycle. And now that nuclear supplier guidelines have been relaxed for India, we are able to import uranium from many countries. And India, you see, this is where the energy demand is. Unless our per capita energy consumption goes up by 6 to 8 times, India cannot become a developed country. That's why all energy options are important for India, including nuclear. And in those countries where nuclear has slowed down, knowledge disappears. You cannot afford to have a technological discontinuity, particularly in high technology. It's not happening in India, or for that matter, China. That's what I used to tell my Western friends some years back. We need you in the short term, you are going to need us in the long term. See, nuclear model of indigenization. There are two methods India has used. It went for international collaboration in the early years. Canadian, the pressurized heavy water reactors, we started 220 megawatt, they were with Canadian collaboration, what we call CANDO. But then the 540 and then the 700 megawatt, they were all built by India. You know, when we did the so-called peaceful nuclear explosion experiment in 1974, Canadians halfway through cut off collaboration. And all the remaining equipment, halfway through, equipment supply was terminated. And then our own Indian companies, it took time for us to indigenize. This is what I call progressive indigenization. The first fast breeder test reactor was done with French collaboration. But the 500 megawatt prototype fast breeder reactor is our own design. Of course, we can also do suo moto indigenization. We can do it all on our own. The light water reactor, which is the nuclear submarine, is our own design. And so on. We can. And then we are willing to make our, since he has Yukiya Amano said, Director General of IAEA, we have a lot of knowledge. We are willing to share it. That is why we are setting up in Haryana this Global Center for Nuclear Energy Partnership. It will have 5 schools, which are names are given here, dealing with nuclear security, radiological safety, advanced nuclear energy system studies, nuclear material characterization, radioisotopes and radiation technology. So it works both ways. Major facilities, GMRT, Giant Meter Radio Telescope. People are using it, Hanley telescope. We are making, that's in Ladakh, under DST, we are willing to make available to the international community. Prime Minister Modi and the French President François Hollande declared this International Solar Energy Alliance because renewable energy is very important for India. Only you must take care of this intermittency of this renewable source. And the secretariat of this International Alliance is in Gurgaon in this National Institute of Solar Energy. There is also a National Center for Photovoltaic Research and Education in IIT Bombay, and of course international US-India collaboration, this institute, what we call CDS in Indian Institute of Science, Bangalore, and this Renewable Energy Lab National in Colorado. DPT has a very interesting method of developed a new paradigm of collaboration. It is a model which can be followed in many areas. They have an Indo-Japanese collaboration. What they have done in the area of advanced biomedicine, 2 labs are sister labs. One in Tsukuba in Japan, in the AIST Industrial Science and Technology Lab, and the second in India. They can have also other sister labs. So they are on equal partnership basis. As I said before, today's India is looking for international collaboration on an equal partner basis. And this is something one could develop. More examples of this, I'm sure, will come. Food crops. See, the germplasm, particularly in the context of the climate change threat, you must be able to exchange germplasm. And I saw a little while back, this lab in this Center for Genetic Manipulation of Crop Plants in the mustard lab, which is a major oilseed crop, Professor Deepak Pental. And here they have mixed Indian gene pool and the East European gene, produced a hybrid which gives 30% more production. They have replaced the same 3 kinds of genes which the Canadians replaced in rapeseed and mustard, Indian mustard. They are somewhat brotherly relationship. And this availability of this exotic germplasm from East Europe was a big startup, good point for that group, the University of Delhi group, to do that. You see, we must have center of world-class facilities. India needs world-class facilities. And this actually started with discussions in our office, Center of Excellence in Nanoelectronics. We said 100 crores we had to spend. Instead of giving it away, 1 crore here, 2 crore there and all that. Let us select through open discussion 2 centers where we will set up world-class centers. And from this open discussion came out Indian Institute of Science, Bangalore, and IIT Bombay. And it is also available for users from other labs. What Professor Rudra Pratap and Professor Juzar Wazi gave me are just slightly dated, a few months old slide. 500 projects have been taken up, collaboration with various university users, 300 institutions, 300 papers are there, and 30 patents. And the moment you build a world-class facility, you are able to attract young faculty from abroad. And in this center, young guys from Stanford and Cornell and IMAC, Belgium, who have a lot of expertise in this field, have come and joined these labs. And many countries want international collaboration. The list is given over there on the left, IIT Bombay and Indian Institute of Science. National Knowledge Network, Dr. Narayan Rao mentioned this, Indian National, it is a research and education network, though it can also be used for governance, like 28 state data centers are there, but basically it connects, it's a research and education network which connects more than 1,600 knowledge institutions in the country. All national labs, all universities, and you can have, I'll show you for a moment, show in a moment, you can use it in various ways. Suppose there are specialists in brain research, we have got a brain grid, coordinated by the National Brain Research Center. All those who are working in Alzheimer's or dementia, maybe stroke, to the extent they want to exchange their MRI or other images, which requires a lot of bandwidth, they can do that using this NKN grid. You have a grid for climate science. You can access the synchrotron radiation source in Grenoble sitting in Bombay, protein crystal. You send a dozen protein crystal, put on a robotics arm, comes before the X-ray beam line in the European synchrotron source. The image comes over here, they decide which is the one which is diffracting the best. Choose that and you can collect the entire data. Of course, you need some assistance from the scientists at the European. And you can do it, all of them decide, okay, this crystal looks, instead of sending one person, one young guy who has to take the decision, here the entire group can take the decision. And now, this is a wonderful project executed by the National Informatics Center of DIT under the guidance of R.S. Mani, who is the project director. And we have created what we call POPs, points of presence, at Amsterdam and Singapore. At the moment, since the Internet 2 ends in, also has a node in Amsterdam, from there we go to the Internet 2, which is the REN, Research and Education Network of the US. But we will also have a POP in New York, we'll have a POP in Geneva, and through the Singapore, we are connected to all these Singapore, REN, GIANT, this European, and then from Singapore you can go to the other East European countries. Big data science, it is because there is what somebody has called data deluge now in astronomy, in astrophysics, biology, and in climate science. You need supercomputers for handling this data. You need large storage systems for doing this. And our office has launched a project. And each one of these disciplines, astrophysics has some very interesting methods of data mining or deep learning maybe, and whether the best practices can be brought to, let us say, biology or climate science. And these also require international partnerships, because the data they handle, whether it's astrophysics or biology, these are data banks outside which they will be able to access. What we are trying to say is, in each one of these areas, choose a nodal institution. Astrophysics, let us say Indian Institute of IUCA or Indian Institute of Tropical Meteorology in Pune in the case of climate science, or Regional Center for Biotechnology in the case of biology. You can have subsidiary centers. Main data bases will be located there. But in the Shastri Park, which is the headquarters of NKN, we will keep a mirror site. Anybody connected to an NKN node can access this data. And if you want to do more careful, if you want more information, then you can go on to the database center, which has domain knowledge. This is a thing which I got from Professor Vijay Raghavan, Professor K. Vijay Raghavan, Secretary DBT. How research, this is a nature index. And you can say India has collaborated a large number of US and Germany, UK, France, and this is only going to grow. And today's India is able to give as much to the world as it wants to take from it. And finally, let me come to my last slide. All of us want India to become a knowledge economy, first a developed world, then you become a knowledge economy. Able to generate knowledge, or able to also to appropriate knowledge generated in any part of the world, for which you need this excellent R&D ecosystem backed by high quality manufacturing skills. And we must take, particularly young people must take the opportunity of the large number of scientists you meet here, both from India and from abroad, or scientists also, to establish relationships. See, the ultimate analysis, science is done by scientists, and collaboration is among scientists. Institutions can give you the support, but finally it boils down to individual scientists. And I'm sure the Science Congress has given you an opportunity. Of course, so many meetings take place in specific domains. All those opportunities we must now make use of in order to establish more and more international partnerships for mutual benefit. No partnership is sustainable unless it is mutually beneficial. And I have a feeling India can give as much as it wants to take from the world. Thank you very much.